Hi, we're going to look now at a hyperbola problem. We have to find the center, foci, and asymptotes of the equation of the hyperbola x squared minus y squared equals 1. We're going to follow the same steps that we usually do. We will first compare this with the standard equation of the hyperbola, x squared over a squared minus y squared over b squared is equal to 1. We're in luck in this problem because it's been given to us in quite a nice form. All we have to do to reformat it, to make it resemble the standard form even more, is rewrite it as x squared over 1 minus y squared over 1 is equal to 1. So now we have this equation in standard form. So how do we proceed from here? What can we learn about the hyperbola from this equation? First of all, we can tell the center is 0, 0. We know it's 0, 0 because if it weren't, let's say it were 1, 2, this equation would be x minus 1 squared over 1 minus y minus 2 squared over 1 is equal to 1. But it's not. So we know that in this case, just like in the case of a circle and an ellipse, the center is 0, 0 because you just have x squared and y squared as it stands. How do we find the foci? There was no room for this relation in the previous video, so we're going to introduce it here. You came across a relation which said b squared is equal to a squared times 1 minus e squared when it came to ellipses. A similar relation does exist in the case of hyperbolas, but instead of 1 minus e squared, it's e squared minus 1. So in the case of a hyperbola, b squared is equal to a squared times e squared minus 1, where a refers to half of the axis length of the hyperbola. If we substitute our values into here, because we know what b squared and a squared are from this equation, 1 is equal to e squared minus 1, e squared is 2, therefore e is square root 2. And ae is therefore going to be square root 2. Before we continue on, let's just think for a moment. What does this hyperbola look like? We have no reason to believe that it does not look like this. It looks like a sort of standard hyperbola with a C shape and an inverted C shape. We know the center of this hyperbola is 0, 0. Remember, we said that the foci will always lie a times e units away from the center on either side, where a represents half the axis length. We know that a in this case is 1. So, if a is 1, and we found the eccentricity, ae is 1 times root 2, which is square root 2. So, just drawing the hypothetical axis here, let's extend it a little bit further for the sake of illustration. The foci would lie here and here, roughly. And they would lie square root 2 units in this direction of the center, and the other would lie square root 2 units in the opposite direction to the center. Hence, because we know the center and we know the distance from the center to each of the foci, we can establish that the foci lie at root 2, 0 and minus root 2, 0. Finally, what about the asymptotes? Let's just clean this a little bit to make the asymptotes a bit easier to understand. We said that these curves in the hyperbola don't go on forever. They do stop, and they are stopped by a couple of asymptotes which form a sort of X shape at the center, like so. We said that the equation of the upward sloping asymptote would be y equals bx over a. Applying that formula to this problem, we know the value of b is 1. The x remains as it is because the center is 0, 0. So you write that as 1 times x over a, which is 1. Therefore, the equation of this upward sloping asymptote is y equals x. We said the equation of the downward sloping asymptote is y equals minus bx over a, which is equal to, if we substitute, minus 1 times x over 1, which is minus x. This might seem a bit confusing, as I've mentioned several times, but the key is keep practicing and you'll get to grips with it. And also, as I stress, do carry out the calculations by yourselves as I'm carrying them out, otherwise you won't really learn anything. You'll be astounded how much you learn simply by writing things down on paper and following through with your own thinking. That concludes our work on conic sections. Thank you for listening.